Hello and welcome to this new video. Today we're going to set up a site-to-site VPN between our company and a third party, which could be, for example, a consulting office, an external SOC, and so on. Then I'll also tell you about a real-life example that happened to me a long time ago. What I am going to show you today is this particular very interesting lab right here, which is quite fascinating. All right, let's take a look. I'll grab this screenshot and explain it to you right away. So, as I said, this is our main company, the headquarters. This is the third party, which could be a consulting firm, an external SOC, or another office that is temporarily helping out my main office, and so on. You should know, for those who have never worked inside large companies, so enterprises, that big companies have many IP addresses, obviously many VLANs, and these IP addresses, these networks are assigned and are used for specific purposes, for example, the warehouse office, the meeting rooms, the HR department, and so on. So, for example, you might have a network like 192.168.1.0/20, which has a lot of IP addresses. These IP addresses are reserved both internally for remote offices and for all other branches that are part of the parent company, so the main company. Now, I don't want to assign a network, as I said, to an external office, to a SOC, or to a third party. So I have two solutions. In this case, I use the Palo Alto firewall. For example, I could use Global Protect, so the user here, the third party, let's call them that, connects to the main company using Global Protect, and that's a good solution. I'm not saying it's the absolute best because clearly the performance is a bit lower, but it's definitely doable. Or I set up a site-to-site VPN, like in this video, and it's behind the NAT. In this case, 172.16.1.24 for my company's side. So for the main office, it's 172.16.2.0/24. I share and send all the data from this company behind this IP address. So it's an address I can easily recognize in my main office because it's external and clearly not part of my network. This also translates into higher speed. Let me tell you a little story. When I was working in Formula One in England, we moved to Dallara, where they make chassis for race cars. When we arrived at that location, in that office, our network already had all the equipment, all the hardware pre-configured. Unfortunately, it was the same IP address that was also used at Dallara. So we use this method with NAT, and this is one of the many reasons why you might apply this solution, because the configuration itself is simple. What's important, though, is understanding where a certain configuration can be applied and the reasons for doing so. So let's move on. To configure our NAT, let's start from site A. Here we have our firewalls A and B, and I'll show you right away how it's done. The configuration is very simple. So first of all, let's add a static route. We will now click on the Add button, and let's proceed to call this, for example, route from A to. And here we explicitly tell it, if you specifically want to reach the particular 2.0/24 network, you should definitely use the tunnel interface without any next hop whatsoever. That's it for now. Then we go on to configure the policies, so under security policy here on the Palo Alto firewall, and we'll configure two, one for outgoing and one for incoming data. So we'll call it from A to B. Source inside the destination address and source address. In this case, I leave them as any, but clearly in production, you need to be specific with source address and destination address. For destination zone, we set outside and for application, all of them. Then since this policy is the same and only the name changes, I just click on it. Clone, click OK and only change the name, entering from B to A. For source, obviously, VPN A to B, which is the zone for the VPN, and for destination inside. And that's done. Now let's move on to the NAT part. In this case, I want to reach this computer because I want to access this computer. And I'll explain why. So let's take our screenshot. As the parent company, maybe I've leased them the firewall, or for other reasons I need to manage their hardware. Let's pretend this is a switch here. We also have some access points, for example, which are these two dots. And obviously this is a computer, but it could be anything else. I need to be able to access their network via VPN and, for example, manage the firewall, manage the switch, manage the access points, and so on and so forth. Let me remind you that this network is 100. This network of this computer here is 192.168.1.0/24. This network is 192.168.1.0/24. They are the same, so that's an additional problem. So let's continue with our current configuration. Let's proceed to open our firewall settings, allowing necessary connections. Let's go to NAT and add a rule, and we'll call it, for example, NAT 1-to-1. Now, in this specific case, I'm just giving an example because I actually have only one device, but each device corresponds to an IP address. So let's pretend it's from HQ. So HQ to ping, for example. So source zone VPN A to B, meaning the data coming from A to firewall B. Destination zone outside. Interface outside. For the source zone, I will enter the IP address of the native network of firewall B, which is 2.1. With a destination address of 172.16.1.2, the translation packet's destination translation address is IP 192.168.1.2. Now, I will proceed to create another example to further assist you in understanding this concept more thoroughly, because I will, in any case, explain it to you comprehensively. For instance, let us perform this one-to-one network address translation, or NAT, from HQ to SSH, for example. The policy configuration is practically the same, so we define the source zone to be the internal network and the destination zone as outside, specifically targeting the external internet. The interface used will be the outside interface, which connects to the public network. The source IP address is 172.16.2.1, which precisely represents the network of Firewall B, essentially the main company's internal network. The destination IP address in this particular case is 172.16.1.3. For translation, we are implementing destination translation, where the address IP addresses will be 192.168.1.3. After configuring these parameters, I can click Apply to save the changes and then commit to activate them across the system. Now, if you're not very familiar with the concept of one-to-one NAT, which is network address translation, I will thoroughly show you what we've just accomplished and explain its implications in detail. Basically, what we've just done is I've told it, look, all of the comprehensive data, including the specific IP addresses that you receive from this particular network, is available. Specifically, the IP address 1, you absolutely have to perform network address translation, or NAT, on them, meaning you essentially have to translate them into 192.168.1.2 because this computer is .2. To reach this point 2, I have to type 172.16.1.2. Then, if I wrote SSH, which could be any device, let's pretend it's an access point, I wrote .3. So if I type from this computer 172.16.1.3, it will correspond to 192.168.1.3, and so on. I hope that's clear, because if you don't have much experience with one-to-one NAT, sometimes it can get a bit confusing. But with a bit of practice, it's nothing difficult. This, on the other hand, is firewall B. So we're on this side now. As before, we are discussing the fundamental network routing configurations. Specifically, we will be looking at the essential default route and also the static route, which we'll precisely call route 2A. So if you want to reach the 172.16.1.0/24 network, use the tunnel interface and with no next hop configured. Okay, then we go and specifically create the security policy, and we create this one. We'll clearly call it from B to A. Source inside, obviously. Destination designated. Zone that I created for the VPN, so B2A. This is just a sample name. As I said before, I don't specify any source or destination address. I leave it as any, but in production you need to specify it, just as you need to specify the applications you use. I recommend using applications and not services, meaning ports. It's better to use applications for application inspection, but that's another story. Then we also create a return policy. So from A to B, source zone, VPN B to A, and the destination zone is inside. It's done. Then finally, we have our network address translation, or NAT, which is a crucial component. We will proceed to add it, and for our purposes, we will specifically call it NAT from HQ, indicating that it is originating from the main headquarters. To A. Original packet inside, the zone obviously is the destination zone, the VPN zone, the tunnel interface, and this time we select tunnel interface 10 in my case. Source address, here we specify the entire network 192.168.1.0/24, and we enable the whole network as destination 16.1.0/24. At this point, finally, we tell it to translate, so dynamic IP import to 172.16.2.1. We click OK, commit. And let's see if it works. In the meantime, I'll take the Linux computer, which is this particular computer system here, obviously this specific computer. So from this very computer, I will now attempt to ping this other computer. I have unfortunately lost the connection to the Linux computer. Let's type ping 172.16.1.2 and see if it works. Here it is, the ping works. At this point, I have access. In this case, I have ping, but in any case, I can have access to my networks. So this is inbound NAT. But as I said before, company A, so the third-party company, must be able to communicate with some websites of my company. So, to be much more precise and accurate, here in this particular instance, we will write the word inbound very clearly. Because when you use these NAT 121s, it could be that you have many rules. Inbound. So, if instead we wanted to create an outbound rule, because, for example, I want to use the DNS of the main office, which I actually have to use if I want to access company sites, then I would write NAT. In this case, one to many and many to many, but NAT from to the HQ DNS, for example. So the original packet obviously is inside the destination zone VPN. The zone itself utilizes the tunnel interface. And here we specifically indicate that the entire network, which is 192.168.1.0/24, with a destination address, let's use some imaginary IP addresses for illustrative purposes. For example, let's say 10.0.0.1, which could potentially be a primary DNS server, and then 10.0.0.2 serving as the secondary DNS server, and that's essentially it. Subsequently, the translation packet goes to 172.16.1.1, which is precisely the address of my native network. I will now click OK. Here we have set it to be outbound so that it is much easier to distinguish, specifically outbound. Okay, and I click OK. And commit, there you go. And that's how you configure one-to-one NAT. Clearly I did it with a Palo Alto firewall, but you can do it with any router or firewall because the process is the same. But what's really important is the reason why you do something and where it can be applied. So thank you for watching this video. If you liked it, leave a like. If you haven't subscribed yet, subscribe to the channel and see you next time. Oh, and leave a comment. If you've ever needed to set up a VPN like this, let me know. Thanks, and see you next time.